Welcome to ClickMyProject.com. Let we discuss about the process automated vessel segmentation using infinite perimeter active contour model with hybrid region information with application to retinal images. Let us see the abstract of the process automated vessel segmentation using infinite perimeter active contour model with hybrid region information with application to retinal images. The segmentation of blood vessels in retinal images were helpful in the identification of diseases in retinal images. Identifying and locating blood vessels in fundus images is a critical process since the blood vessels were very similar in intensity compared to the other images in the intensity. Edge detection process is applied to the input images in order to identify the vessel regions initially. While applying the edge detection process, the regions other than the blood vessels were also obtained from the image. The face of the images were obtained, and based on the obtained face, the edge regions left this level set segmentation process is employed in order to segment the blood vessels regions alone from the input images. The performances of the process is measured based on the performance matrices like accuracy, sensitivity, specificity, area under curve, and dice coefficients of the proposed process. The basic processes in the vessel segmentations in the proposed method includes the detection of edge regions in the input images based on canny edge detection method, and then face enhancement, which is done based on identification of the face of the input images, and the left level set segmentation, which is based on the development of the identified blood vessel pixels based on the comparison with the neighboring pixels and based on the energy calculation of the processes. And finally, the level blood vessel regions extracted, the performances of the processes were measured based on the performance matrices. Let us see the flow of the process. The input fundus images were obtained from drive dataset. Fundus images depicts the blood vessel regions and the optical disc regions in the retinal images more effectively, and hence they are used for the vessel segmentation processes. The fundus images were first edges in the fundus images were identified based on edge identification process, and after that the vessel identification process continues. For the identification of the edges, the canny edge detection operator is employed, and after that for the vessel identification process, the ellipsis level set segmentation process is employed. In the ellipsis level set segmentation process, the regions in the blood vessels were classified into vessels or non-vessels. That is, the initial point of the input images were grown in order to develop the blood vessel regions, and after that the local phase identification is done. The local phase identification denotes the regions with the blood vessels in the input images. Finally, the vessel regions were segmented from the input images. The outer edges were obtained in the step of the level set segmentation and the local phase identification processes. And for the vessel segmentation, the pixels that were present inside the inner edges were alone identified. Finally, the performances of the processes is measured in terms of accuracy, sensitivity, specificity, area under curve, and dice coefficients like that. So the extracted performances measured denotes that the proposed system is capable of the identification of blood vessels in the drive dataset more effectively. Let us see the running procedure of the process. If you want to run the code, select the file main.py which is present in the dataset folder. Right click it and click on run file. You will get the process executed. select any one of the images which is present in the dataset and select open. The process will be started. This is the input image that we have selected. This is the energy image obtained from the input image based on the infinite perimeter active contour model. So this process is used for the identification of the energies in the images, and based on that the vessel regions were identified. The initial vessel pixels were initialized based on the obtained energy images. So this is the initial position for the vessel pixels. These regions were developed in the further process. This is the outer edge of the input retinal images that we have obtained. So the blood vessel regions will be inside this inner edges only. These were the initial blood vessel pixels identified. So from here the pixels within this particular inner regions were alone selected, which identifies the blood vessel regions from the input images. So this is the finally identified blood vessel regions, and from that we can get the blood vessels from the input retinal images based on the infinite perimeter active contour model. Finally, this is the performance measures that we have obtained. But the accuracy, sensitivity, specificity, area under curve, and the dice coefficients. These were all measured as the performances for the proposed method. So from the performances obtained, we can see that the proposed method identifies the vessel regions in the derived dataset more effectively. Thank you.